So let's start off by talking about how you test a single parameter. Single parameter. All right, so we learned about the steps, we reviewed the steps to hypothesis testing. So let's say we have a regression. We'll go over the theory kind of first and the steps, and then we'll do an example so we can kind of see it in action. Let's just write out a general plus beta k xk. So let's leave it nice and general. And we're going to make, the assumptions, all these assumptions that we were making before. So we have a normally distributed error term, mean of 0, a variance of sigma squared. Okay, and so the first thing we're going to do is define, the first step is kind of specify our null and alternative hypothesis. So this is that we're making a hypothesis about the true value. It's not about our beta hats. It's about we want to test the true value, whether we can make a conclusion about the true value of this parameter using our sample, right? That's the whole goal that we're trying to do with stats. All right, so for instance, we want to test whether beta j equals some number. So I'm going to write beta j comma 0 as just some number. Example 0. So for instance, we could test our null hypothesis that beta j equals 0. So the jth parameter here. So maybe I'll put example HO beta j equals 0. But just some number there. Like we're testing whether this parameter equals some number. You can have one or two-way tests. We're just going to concentrate mostly on two-way tests in this course. So let's just make it a two-way test. And so the alternative would be that it doesn't equal beta j 0. So the alternative would be, well, let's write HA that beta j doesn't equal 0. But it's just some number. It could be 1, it could be 2, 10, a million, whatever. Okay, so remember that was that first step. The next thing we need to specify some significance level. So it could be 5, 1%. Usually we test at 1, 5, and 10% in economics. Or we calculate the p-value, which kind of gives us more information. So that was that first step. The second step, let's say we're going to test, maybe we'll just say test, but we'll say alpha equals something like 0.05. So we're testing, we're willing to make type 1 error 5% of the time. So our threshold for type 1 errors is 5%, for instance, but a lot of times you might just test at 1, 5, and 10% anyway. Okay, so our thresholds, so that's the second step. The third step is going to be to calculate our test statistic. And so to test a single parameter, we're going to use a t statistic to test for this. And so use a t-stat. And now, t-stat is t-statistic, or a t-ratio. Maybe I'll say a t-ratio. So we're not using the same language over and over again. And so this t-statistic is going to be calculated this way. Or maybe I'll actually say t-ratio. A lot of times you'll just put kind of t in there. But the t-ratio is going to be whatever our beta hat j was from actually running this regression. So we ran this regression, and the jth, could be beta 1 or beta 2, whatever beta where this j is equal to. J is equal to 1, then it's beta 1. Then we're going to subtract what our hypothesized value is. So whatever this number is, so for example, we'd subtract 0 if we were testing whether the null equals 0. And then we're going to divide by the standard error of beta hat j. So remember, in our regression results in R or in Stata, whatever we're using, we can also calculate the standard error. We're just going to divide by that standard error. And this t ratio is going to have a t distribution, a student's t distribution, with n minus k minus 1 degrees of freedom here. So remember, n is the sample size, so the number of people or firms or whatever that we're looking at in the data set. This k is the number of independent variables, and minus 1 is for that extra intercept that we have there. So you can always think of it as n minus k plus 1, right? We talked about that before. This is the number of parameters that we're estimating. All right, so then we calculate this t ratio. We're going to get some number from this, right? This will equal some number. We'll see in a second when we actually calculate it. And then we're going to do one of those two things to come to a conclusion of our test. We're either going to look up the critical value for this alpha. So maybe I'll erase this and write it again, or maybe I can go up here. So so remember option A, if our t ratio, I'm going to take the absolute value, is greater than the t critical, then we're going to reject the null. And again, the critical value is going to, those are those big tables that sometimes you looked at in the back of your book. I think it's in the back of our book again. You look up the critical value for this distribution, this t distribution with n minus k minus 1 degrees of freedom. And you'll reject the null if your t ratio is greater than your critical value. Otherwise, you'll fail to reject the null. Otherwise, fail to reject. Hoping this is all still on the screen here. And remember, option B was to use the p-value. If the p-value was less, notice that this one's greater and this one's less than, because the greater the t ratio, the smaller the p-value. Or as Dr. Gregor Smith liked to say, big T, little p. So if this is greater than alpha, or sorry, less than alpha, we reject the null. Otherwise, fail to reject. Okay. All right, I guess I should put less than or equal to and greater than or equal to. All right, so these are the steps to testing a single parameter. So we're going to specify our regression. We've made these 6 assumptions that we talked about. We're going to run that regression. So we have beta hats, so we have estimates for all of these betas, our OLS estimates for all these betas. We're going to specify our null hypothesis. So this is that the true value of the parameter equals some number, which I'm denoting beta j comma 0, so not, I guess is what I actually mean by that. Example, beta j equals 0. The alternative, we're going to concentrate on 2 ways. So it's that this doesn't, what happens when this doesn't hold? Well, that means beta j doesn't equal this number. We're then going to specify our significance level, so our threshold for making a type 1 error, our threshold for rejecting the null when it's true. And then we're going to calculate our test statistic. Remember, that was the 3rd step. So here the test statistic is going to be the t ratio. And we're going to take our beta hat j, we're going to subtract what our hypothesized value is here in our null hypothesis, and we're going to divide by the standard error. We're going to get some number here when we actually run a regression. We'll do an example in a second. In this test statistic, this t ratio has this distribution. It has a student's t distribution with n minus k minus 1 degrees of freedom. And so we need to know this distribution so we can either come to a conclusion about our test either through this critical value or this p-value method. And so the critical value method is we're seeing, we're basically looking up the value that this t would need to be for 5% of the distribution to be in the tail. So what we're actually doing here at this critical value is the critical value t crit here, the negative and the positive, it's a two-way crit. We're picking it such that the sum of all this, all the area in the tails, like all the way up to negative and positive infinity, would be equal to 5%. I mean, that's how we're getting these critical values. And so we're going to reject the null if this t ratio that we calculate, the absolute value of this t ratio, is greater than this critical value, because that would mean that we're further in the tails. So the probability of committing a type 1 error is smaller than 5%. So if this was true, we'd have, that's where our actual t ratio would be, for instance. Otherwise, we can actually plot our, we can think about calculating our p-value, which we're taking our t ratio, we're putting it, we know the distribution, and we're basically calculating the areas to the left and to the right of our actually calculated t ratio. And that's going to tell us the probability that we are committing a type 1 error, given the null is true. Okay, so let's look at a quick example to hopefully clarify some of this, and then we can move on to different kinds of tests we might want to do.